Hi viewers, welcome to Interesting Chemistry. In today's session, we are going to solve few problems based on stoichiometry. That is nothing but stoichiometric calculations. Stoichiometric calculations. Let us solve the first problem. How many moles of nitrogen are needed to produce 8.2 moles of ammonia by reaction with hydrogen? In the previous video, we have discussed the steps to be followed in stoichiometric calculation. What is the first step? Writing the balanced chemical equation for this sum. So here nitrogen combined with hydrogen, it produces ammonia. This is the chemical equation for this sum. Then we should balance. How many nitrogen here? 2 nitrogen, but here only 1. So we will make it into 2 by adding the coefficient 2 here. Then hydrogen, 6 hydrogen, here only 2 hydrogen. So multiplying this hydrogen by 3, we will be getting 6 hydrogen. So all the atoms are balanced on both the side. Then second step, finding the correct relationship to be used in this problem. So we are going to find out the correct relationship. How can we find out the correct relationship? Here again we read the question, how many moles of nitrogen? They have asked number of moles of nitrogen. What is given? 8.2 moles of ammonia. The given values also in moles. They have asked the answer also in moles. So this problem is based on mole-mole relationship. So what is asked? How many moles of nitrogen? That we will write on the right side. NH3. How many moles of nitrogen? So N2. In what form it is asked? Moles. Then what is given? Ammonia. Ammonia in what form it is given? That is also in moles. So mole-mole relationship. Then according to balanced chemical equation, according to balanced equation, how many moles of ammonia is produced? 2 moles of ammonia. The same relationship we have to follow in balanced chemical equation also. So here mole-mole relationship. So 2 mole of ammonia is produced when 1 mole of nitrogen is used. The substance, given substance, which substance is given here? Given substance is 8.2 moles of ammonia. How many moles of nitrogen is needed here? So we have to put a interrogative sign in this place. First, balanced chemical equation we have written. Then we have found out the relationship. Then third one, apply the same relationship in balanced equation also. Next we have write the actual quantity of the substance. Then at last we have to find out the result by unitary method. Number of moles of nitrogen. Number of moles of nitrogen equal to 1 mole of nitrogen is needed to prepare 2 moles of ammonia. So this will be giving the value for single unit. If we divide 1 by 2, 1 mole of nitrogen will be needed for the production of 2 moles of ammonia. Means for 1 mole of ammonia, how many moles of nitrogen is needed? So this will give the value for single unit. That's why we are calling it as unitary method. Into for 2 moles of ammonia, 1 mole of 2 moles of ammonia, 1 mole of nitrogen is needed means for 8.2 moles of ammonia, how many moles of nitrogen is needed? So, we can find out 4.1 moles of nitrogen is needed for the preparation of 8.2 moles of ammonia. Let us try to solve next problem. What mass of calcium oxide will be obtained by heating 3 moles of calcium carbonate? Heating 3 moles of calcium carbonate. This reaction in 10th standard we have studied calcium carbonate. On heating, it will be producing calcium oxide plus carbon dioxide. Balance 1 Ca, here also 1 Ca, carbon 1, here also 1, oxygen 3, here also 3. So, it's self-balanced. Next step, what relationship we should find out? Mass of calcium oxide is asked. It is given moles of calcium carbonate. So, mass mole relationship. What is asked? Calcium oxide is asked, that we will write right side. In what form it is asked? Mass. Then what is given? Calcium carbonate. In what form it is given? Moles. According to balanced equation, the same relationship we are going to use in balanced chemical equation also. So, here CaCO3 in moles. So, 1 mole of CaCO3 produces how many grams of calcium oxide? So, here we have to take calcium oxide in mass, because in the question the relationship is mass mole relationship. The same we have to follow in balanced chemical equation also. So, here calcium, its mass is 40 plus oxygen, it is 16. So, 56 gram of calcium oxide. What two things it's interrelated in the sum, the same two things we can interrelate in the problem also. We no need to write unnecessarily carbon dioxide mass and all, we no need to consider. Only what two things interrelated, the same two things we will write here. So, calcium carbonate, for 1 mole of calcium carbonate, 56 gram of calcium oxide is produced. According to the question, substance given is 3 moles of calcium carbonate, interrogative sign here, this only we have to find out. So, mass of calcium oxide equal to, for 1 mole of calcium carbonate, 56 gram of calcium oxide is produced. For 3 mole of calcium carbonate, how many gram of calcium oxide will be produced? If we multiply these two, we will be getting 168 gram of calcium oxide is produced. So, what are the two things interrelated in the question? The same things we have to consider here. Unnecessarily, we no need to include the other things and all. Let us see the next problem. Calculate the weight of iron which will be converted into its oxide Fe3O4 by the action of 4.4 gram of steam on it. First, let us write the balanced chemical equation. Iron is reacting with water. It produces Fe3O4 and hydrogen. Next, let us balance. here 3 Fe, so here also 3 Fe. Oxygen here 4 oxygen, here 1 oxygen, so let us write 4. Then hydrogen, here 4 into 2, 8 hydrogen, so here also let us write 4 hydrogen molecule. Next, what relationship we should find out? Weight of iron will be converted into its oxide by the action of 4.4 gram. This is also mass. So, the relationship is mass-mass relationship. What are the two things interconnected? Iron and steam. Only these two things. So, iron in which form it is? Mass. So, one iron, its molar mass is 56 gram. Molar mass of iron is 56 gram. So, 3 into 56 gram of iron combining with 4 into 18 gram of oxygen. In what relationship in the question it is given, same relationship we should follow in the balanced chemical equation also. So, here Fe and H2O, only these two things interrelated. So, we will also use the same two things Fe and H2O. So, what is asked? Iron. Calculate the weight of iron. Fe is asked, its mass is asked. So, Fe in terms of mass. Then what is given? Water is given, for that also mass. So, according to balanced equation, water 4 into 18 gram of water needs 3 into 56 gram of iron. Substance given 14.4 gram of water needs how many gram of iron? Mass of iron equal to 3 into 56 needs for 4 into 18. For 4 into 18 gram of water, 3 into 56 gram of iron is needed. For 14.4 gram of water, how many gram of iron is needed? You no need to multiply these things here itself, because directly if you apply in these places, it will be easy. So, here 6313. Then these two can be cancelled, 2.4. Then here 4, 14. So, 14 into 2.4, we will be getting 33.6 gram. In this sum, calculate the volume of oxygen at Tstp required to convert 5.2 liter of carbon monoxide to carbon dioxide. Carbon monoxide is going to be added with oxygen, it become carbon dioxide. Balance, here 3 oxygen, here 2 oxygen. This also we will change it into 2. So, total 4 oxygen. So, if we write here 2, it will be becoming 4 oxygen and 2 carbon. What are the relationship here? Let us find the relationship. Volume of oxygen to convert 5.2 liter of carbon monoxide, that is also given in the form of volume. So, oxygen and carbon monoxide, these two things they have interrelated. So, that two things we are also going to interrelate. Volume means at Stp it is given 2 into 22.4 liter, because at Stp 1 mole of a gas will occupy 22.4 liter. Here 2 moles, so 2 into 22.4 liter of carbon monoxide combined with 1 mole, so 22.4 liter of oxygen. So here what is asked? Volume of oxygen, right side. What is asked? I have written the right side. In what form? Volume. What is given? Carbon monoxide. That is also given in the form of volume. So according to balanced equation, carbon monoxide, 2 into 22.4 liter of carbon monoxide needs 22.4 liter of oxygen. Substance given 5.2 liter of carbon monoxide needs how many liter of oxygen? Volume of oxygen needed equal to 22.4 by 2 into 22.4 into 5.2. 22.4 cancelled. 2 here 2.6. So 2.6 liter of oxygen is needed. You would have understood how to apply stoichiometry in calculation, I think. In the next video, let us see limiting reagent. Thank you.